Okay, so now we need to start looking at buffers. So a buffer is an area of memory used to store data during the transfer of data to a peripheral, such as a printer or a disk drive, or from a peripheral, for example a keyboard, or again a disk drive. A buffer is always used between a processor and a device to compensate for the differences in speed between them. If there weren't buffers, the CPU would have to constantly monitor the inputs and pass data very slowly to the output devices and be completely tied up with the job it is carrying out. For example, reading from a disk drive, data slowly fills the buffer, okay, and then the CPU can quickly empty the buffer. So the CPU isn't waiting around and monitoring that process. The buffer's there to provide or to free the CPU up to carry out other tasks. So consider a system where a program reads in records from a file, processes the data, and then prints it out. So the disk begins to fill the buffer with record 1. When the disk buffer is full, the processor empties it and begins to process it. The disk begins to fill the disk buffer with record 2. While it's doing that, the processor is able to fill the printer buffer with record 1. And the printer begins to empty the printer buffer, and so on. So basically, the processor can carry out different jobs in the same time frame because the buffers are there to hold the data. Notice that having buffers allows the simultaneous operation of peripherals. Therefore, the operating system can be reading a record from a disk at the same time as it is printing. So double buffering, there is a pause, and it can be lengthy if the operating system is busy after the disk drive has filled the buffer and is waiting for the operating system to empty it. There is also a pause after the the printer has emptied the buffer while it waits for the OS to fill it with the next set of data. The situation can be improved by using double buffering, where pairs of buffers are used with each device. Okay, so you've got your disk drive linking into your CPU. As soon as the disk has filled the first buffer, it can start filling the second buffer without having to wait for the CPU to empty it first. By the time the second buffer has been filled, the CPU will have emptied the first buffer. This means that the disk drive can be continuously transferring data without any pauses in operation. Okay, so scheduling in a multi-programming system. So scheduling is the method by which the processor time is allocated in a multi-programming operating system. In a multi-programming system, several processes may be competing for the use of a processor. There may be several processes belonging just to one person, or a single task, or a single multitasking operating system, or belonging to several people on a multi-user operating system. At any instant, only one process will be running as the CPU can only do one thing at a time. The other processes will be waiting for their turn using the processor or performing some form of input and output. The operating system has the task of deciding which processes should be assigned to the CPU at any particular time, and this is called scheduling. The aim of the scheduler is to try and minimize the jobs waiting to use the processor, and therefore aim to get the jobs completed or using input and output as they are not then waiting to use the processor. A process can be either ready, waiting to use the processor, running, using the processor. Only one process can be in this state at a time in a standard single processor system. And blocked, which means it is waiting to use or is using an input or output device, so it does not need the processor, so it's blocked from using the processor. So really, we can only have one running application. We want to minimize the number of ready processes we've got waiting to use the CPU. We want as many blocked processes as we can because they are then using other peripherals. Okay, so we've got high and low level schedulers. So the high level scheduler decides if a process is allowed into the system in the first place. It may reject a process if it requires too many resources. For example, too much memory, or the system is already running too many other processes. The low-level scheduler decides which process should be chosen to run next. And there are many different things that you could look at to decide this, including the scheduler should try and favor input-output bound devices rather than processor-bound processes. The scheduler should try and be fair and take into account the length of time a process has been in the queue. And a well-known low-level scheduling policy is called round-robin scheduling. So if we have a look at the life cycle of a process, we've got our high-level scheduler, and our process is ready to use the CPU. This is then passed to the low-level scheduler, and it is allowed to use the processor so it is running. The program ends. It times out, and then the next process, we can refer to the next ready process. From running, it can also become blocked, so it performs an input or output operation. Once it's completed the input or output, we can then go back to the next ready operation. In round-robin scheduling, the processes are all queued in a first-in, first-out manner. If a process uses the processor for a longer than its allocated time slice, it goes to the back of the queue. Some higher priority processes could be given 2 or more time slices. So a process enters the system. Notice that 2 and 5 have 2 time slices as they are a higher priority. And basically it filters out, so it's every process goes out as it's been completed, unless it hasn't been completed in its allocated time slice. Okay, so the process times out and goes back to the back of the queue. Okay, and then process number 2 is then dealt with. Okay, so multi-programming exam questions. High mark exam questions are often asked for details of functions of the operating systems that allow multi-programming to take place. This brings in lots of areas of this topic as it relies on time slicing, scheduling, memory partitioning, and interrupts. Typical answers allowed include multi-programming as a method of benefiting from the speed of a CPU compared with slow peripherals. More than one job is in memory at the same time. More than one job is apparently processed at the same time. A time slice is the amount of time allocated to each job by the operating system. Scheduling allocates time slices to the jobs. Polling is the sequential checking of jobs so that each gets its appropriate share of time. Partitioning is a division of a computer's memory for different jobs. One job is halted if, for example, it is waiting for a peripheral device. Other jobs can now be processed. Paging jobs in and out makes better use of memory. This promotes efficient use of the CPU. Okay, and then finally, this is achieved by the use of interrupts. So that marks the end of this topic. Please make sure you've got your homework sheet filled out ready for next lesson, and don't forget you have your assessment to be revising for, and it's going to be on everything from topics 1 and 2.